to conquer. Thank you. Them. Together with Dr. Spey, and he's also the co-founder of the Parkinson's Research Advocacy Group and patient advisor to the World Parkinson's Congress. Ben also collaborates with the Journal of Parkinson's Disease blog team and much, much more, I would say. So welcome again, Ben. We are very, very excited to have you here. Ben is a fantastic speaker, and we are really looking forward to hearing your talk.
Thank you, Sarah. Thank you for having me, and hello to everyone at the NIH and everyone else that might be listening from wherever you are listening from. And actually, if you could, I'd like to just know a little bit more about where everybody is in the chat box at the bottom. If you could just type in quickly where you're from, where you're listening into. And while you're listening, I want you to look at this picture, or while you're trying to type and find where the keyboard might be or where the chat box might be. I want you to take a quick look at the picture that's in front of you. So I've been diagnosed, as Sarah just said, about 8 years ago now. And for the last 8 years, I've been on a journey trying to answer this one question: what is Parkinson's disease? And I think I've kind of stumbled in some weird ways on what I think is the best answer that I've come across so far. And it really is this picture that's in front of you. I'm going to be coming back to this picture a little bit later, but for now, what I want everybody to do is just look at the picture very carefully. I'm going to give you about 30 seconds, and I want you to close your eyes and think about that picture, trying to blazon it on your own mind, because like I said, I'm going to be asking you to recall it a bit later. So for now, just look at the picture, take a look around if you need to, and then close your eyes and try and just like picture it in your mind's eye if you can. Go. Okay, like I said, I'll come back to that in a bit though, so let's go on. Now, the first thing that I was thinking about when I tried to answer this question about what is Parkinson's disease is what are the different kinds of fields that one needs to know to try to get a sense of this disease itself. And I looked around and I saw that this disease is very, very complicated for a lot of different reasons, but one of them is just because of all the different kinds of knowledge that are involved in trying to understand this disease. I mean, just look at the people that make up the NIH here in DC. You have geneticists, you have molecular biologists, you have people who work on every single conceivable aspect of cell biology as well, all coming together in one place trying to figure out what exactly is going on in this disease. Now, while I'm bolstered by all that brain power and all of that knowledge is coming together to try to figure this out, I do wonder, how is somebody like myself ever going to make any headway in this disease area? How can one person actually, one, gain the knowledge necessary to understand it for themselves, and then two, more importantly, make any progress, not only for the field as a whole, but more importantly, for themselves? Because, and it's something I'll come back to as well, but something I often tell Alfonso Fasano, my own neurologist up in Toronto, is that while patients, we want to contribute, we want to do as much good as we can. At the end of the day, we're pretty selfish people as well. We're just, at the end of the day, all we really care about is getting something that works better for us so that we can feel a little bit better tomorrow than we did today or the day before that. I'll come back to this as well, but just keep that in mind as we move forward. Now, when I think about Parkinson's disease and I look at the literature, I see these kinds of drawings that are often popping up in my field of view. These are the list of all the different symptoms that are associated with this disease. Take a look around, just take a quick look at all the different things that are associated with Parkinson's disease, all the different kinds of symptoms as well, all the different motor symptoms and non-motor symptoms associated with Parkinson's disease. Now, how many of these criteria do you think somebody needs to fill to actually get the diagnosis of Parkinson's themselves? Well, in there, that's where the art of neurology comes in, because there's no like 3 or 4 things I can point to and say, oh, if you have these 3 or 4 things, then you have Parkinson's. It's really like a smorgasbord of all these different symptoms and all these different things that might be going wrong in any one individual that might actually lead them to get this diagnosis, which is why it's very, very important that you have a skilled neurologist at the beginning of your journey who can help you as much as they can along the way. Now, moving on though to my diagnosis myself.
There's a Ben president interested. Ben at the NIH.
Oh. Okay.
Hey Sue, how you doing? Try and mute yourself if you can when you come on.
Sure.
Yeah. So yeah, so this is going back about 8 years now to when I first, so 12 years ago, I first started to notice something was wrong. That's when my symptoms first started to become apparent to me. However, 8 years ago, I found myself in a movement disorder clinic thanks to my aunt, who's a doctor herself. She's a GP. She saw my hands shaking one day, and then she referred me to a movement disorder specialist up in North York, I believe, in Toronto. Now, at the time, I didn't know anything about this disease. So I went online, I looked, okay, what can we find out? What do we know about this disease? I looked and I saw a lot of images like this. Frankly, I don't think I bear much resemblance to this guy. I don't know what anybody else thinks, but this guy here, while he's a classical image of this disease, and while there are some patients actually that do kind of look like similar to him in some ways, I soon realized that one, I did not fit this profile, and two, all the things that are probably gonna work for somebody like him might not work for somebody like me. So what do I do? What did I do? I went back into my memory banks and I thought, okay, so which reference points do I have for this disease itself? What can I actually use that might actually be able to inform me about what's actually going on in my own brain? I looked around and I found this particular image. Well, there were two reference points that I had. One was Michael J. Fox, and the other was this guy, Muhammad Ali. I believe that this is 1996 at the Atlantic Games in Georgia, at the Summer Games in Georgia, in Atlanta, Georgia, sorry. And here he is lighting the torch for those same Summer Games. And I think a lot of people, they look at this image and they say, wow, look at this great man. He overcame, you know, boxing and the United States government and now Parkinson's disease itself. However, when I now look at him, I look and I see, one, I see like the frozen expression that's on his face and the tremor that's in his hand. But more than that, I can see the dystonia as well that's building up in his left finger there, in his left hand there. And that, it's a powerful thing for me to look back at this from time to time and just remind myself of what this guy particularly was going through and how far we've progressed since then. It's only been 25 years since Muhammad Ali lit this torch. And I think you can see the struggle that he's enduring at this time. I kind of wish that I could go back in time somehow and show him what we have available today and give him some of the tools that are available today as well. Because it's amazing how far we've progressed since then, how far some of the tools that we have to our disposal have progressed as well. The next place that I looked was in the literature. And I saw articles that look like this. When does Parkinson's disease begin? And then I want you to try and read that first sentence if you can. There's a lot of people here at the NIH and a lot of scientists and doctors, and they probably won't have any problems with it. But for the lay audience, for someone like me, especially early on, these kinds of articles can be very intimidating, especially because these are one of the first things that I saw actually when I looked into what this disease could be or where my disease might be coming from as well. And I read those sentences like pathological neuroimaging studies, blah, 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 blah. So two of those first four words, I couldn't even understand at the time. I had no idea what they meant. I had no basis for understanding them. However, that didn't daunt me because I was kind of naive enough to think that maybe I could understand this for myself and maybe I could help make some headway as well in this disease area. So slowly, I started to read more and I started to build up my vocabulary and I started to understand what these words meant. And then I started to be able to piece together the whole sentences as well. And eventually over time, I got to a point where I felt comfortable also publishing in the field itself. And I'll come back to that in 1 second, but first I need to talk one thing about something that's a key focal point of the NIH itself, which is genetics and neurogenetics. Now, my journey began over in Nairobi, Kenya, where I was born. I was born to parents from who were Ashkenazi Jews from Poland. And here I am as a baby. I know what happened. Blah, blah, blah. Here's my younger brother, and here are my two parents as well. I don't know if they want to pop themselves on the screen right now. If they can, turn on your cameras real quick, just so they can see the contrast of how we've developed over time. But you don't have to do that if you don't want to. But what I do want you to think about, though, is one thing. So one is that I have a gene that's associated with Parkinson's. The GBA gene, I have something called the N370S variant. And I believe my mom has the same thing, and I have an aunt who I think also has the same thing, and a cousin who also has the same genetic variant. However, there's no family history of this disease at all. There's nobody in my family who's ever even had to deal with anything associated with neurodegeneration before, as far as I understand, although there's some family members here as well. Maybe somebody can correct me if I got something wrong there. But as far as I understand, there's nobody in my family who's ever had any kind of neurodegenerative disease. And yet I have this GBA mutation that supposedly contributes to my Parkinson's disease. However, and as I talked to Sarah a lot about yesterday, nobody can tell me exactly, one, what's going on in my brain, and two, how much does my genetic profile actually contribute to my disease itself? That's a question that we still have not been able to answer yet. So I look to the next best thing, and that is the environment. Now, there are all sorts of environmental factors and all sorts of exposures that are also associated with this disease and with accelerated progression as well. And here are a few of them in a paper that I wrote with Patrick Brennan and a few other people. where we tried to identify some of the main triggers, facilitators, and what we called aggravators of this disease. And if you look, you'll see a whole host of different things that we thought might be contributing to not only the onset of the disease, but also the progression itself and how motor symptoms progress over time. However, I soon realized that a lot of that, very little of that applied to me as an individual. And two, nobody actually we didn't even have any assays, any kind of bioassays that would tell me anything about what's going on in my brain at any time of my disease progression also. Next, I looked at charts like these and I thought, okay, I looked back into the history of medicine and I tried to examine which are the big breakthroughs that we have so far and how did we get there? How did we actually go from actually understanding some little part of the disease and then being able to apply that to whole populations of people? And if you look, there's some pretty astounding breakthroughs in this area. However, then I looked around the field and I'm like, okay, what's available today that might have a similar effect? What is available that might actually help me live a better life for one and hopefully slow down this disease itself? There's only one thing that really came up time and time. Well, there's two. Levodopa, which is a tried and tested drug that we're using to try and treat this, but also DBS itself, deep brain stimulation therapy. As Sarah pointed out before, I'll be spending the next half an hour basically talking about deep brain stimulation, DBS in particular, and the journey that I've been on since then. Now, however, I also need to point out one other key thing, and that is it was not the only option that was available to me because of my position kind of as an advocate and because I've taken such a vocal lead in Toronto in particular. I had these 4 options plus a few more that were all available to me. Gene therapy, focused ultrasound, deep brain stimulation, and then cell replacement therapy. I'm not going to spend too much time unless somebody wants me to, going over what each one of these mean or the ramifications of each. But it was a very complicated choice to make. There's no formula that I go to and say, okay, these are my options that are available. Which one might be best for me? Also, it was further complicated by one other thing, and that is this. This is the pipeline of Parkinson's therapies that are in development from phase 2 and phase 3 trials. And this comes from the Journal of Parkinson's written by Simon Stott, as well as Suboff and Kevin McFarling and a few other people, I think. And they identified what are the what are the main therapies in development and how are we actually going to progress going forward into trying to treat this disease, maybe at an earlier stage than I was treated at. However, I looked around and I started to knock off each one of these one by one. And I quickly just look at those phase 3 trials. At the top, you have something called Linger, and then you have exenatide. So without I'm not here to try and bash anybody's work or anything like that. But I did start talking to patients that were in almost all of these trials, or in all of the trials that I thought were the most promising. And I quickly realized that one, not only were none of them actually helping people today. I mean, it's very hard to know if something is actually modifying someone's progression first and foremost. How would anybody know if something is actually modifying this progression of a person's disease? Well, we don't have any good measures of the disease itself. So how can we actually then assert that this is actually modifying somebody's disease progression? Well, I think the best way is actually by going and talking to people and asking them how they feel before and after they started taking this therapy. At the end, in many ways, that's the best marker that we still have of this disease and what it actually means to individual human beings. Now, coming back to DBS itself and the decision that I had to make. While I think the team in Toronto, they did all that they possibly could given the resources available to help prepare me for this journey that I've been on ever since, there are things that we could be doing as a collective society and as a community of people that are attached to this disease to help patients like myself actually live better lives at the end of the day as well. And these are kind of the 3 pillars that I've identified of deep brain stimulation therapy. What I would say is that if you don't have one of these 3 pillars in place, if you don't understand what these 3 things are to begin with, or if you don't have one of them either at your disposal or in your home, you probably shouldn't be going through this therapy to begin with. So the first one is you need a very good surgical team around you. You have to make sure that the people around you understand where to put the electrodes in your specific brain. Now, this sounds kind of trivial. It sounds like something that is a very kind of easy thing to understand and to identify. But one, it's a very difficult process. It's very tough to know exactly where to put the electrodes in each patient's brain. And more importantly, it's very difficult to also understand very clearly how to best then modify those stimulant, the four points on the ends of those electrodes after they're put in somebody's brain. One quick story that I'll tell though to begin with is why the reason I was able to take this picture and the reason why I'm wearing that frame at that moment actually was because I was scheduled to, my surgery, I believe, is scheduled to start at 8 a.m. on, I think it was June 1st. However, that morning there was an emergency case that came into the office. What that meant, and it was also, I think, the first or second day after COVID, some of the COVID restrictions were lifted, and they could actually start doing surgeries again here in Toronto, or in Toronto Western Hospital. All of that meant that two things for me. One is that that frame that's on my head, I had to have it sit there for about an hour to 2 hours before the surgery actually began. Two, I also saw that every patient that was walking in front of me, because the OR was filled that day with patients of all different kinds, having all different kinds of surgeries as well. Each one of them would look at me with this look of terror on their face and say, wow, what is this kid actually going through? What the hell is that Batman looking frame suddenly lodged into this kid's head? Now this is me 2 or 3 days afterwards, I believe, after the battery was inserted and the tunnels were wired, and the wires were tunneled through my neck. And then they were connected to these two spots that you might see up at the top of my head here. The reason why I want to show you this is because I wanted to emphasize how difficult some of the days were in the weeks and months after the surgery itself. This is not an easy thing for anybody to go through, and we should not be trivializing it in any way. We have to select patients much better than we do today, and then we have to give them more support along the way to help them better understand their own disease and then help them better treat themselves as they go forward as well. That's something that if you want, we can come back to, and I'm happy to answer any questions that you might have here. I'll try to be as much of an open book as I can in answering them. The next thing from the surgery itself was this picture. It shows my eyeball, so you can see me kind of awake there, because I had to be awake for the whole thing. And the reason why I had to be awake was that so we could do this one recording, which I'm gonna play for you now. I hope it's going to work, but we'll see. 1 second. So if you can't hear that, what it sounds like a Geiger counter to me. But this was for me one of the most revealing, one of the most interesting parts of the whole surgery for me. It's the sound of thousands and thousands and thousands of neurons, my own STN, all firing, all excitedly, all kind of at once or sporadically or whatever you want to call it. Now, the reason why it's so interesting is because, and the reason why I had to be awake for the whole surgery is because they needed to listen to that sound, and they need to make sure, and this helped them actually identify where in my brain the right target area was for this electrode. And two, it also helped them to identify which contact points at the end might be best for me. Again, I'll come back to that if anybody has any questions. Second pillar that you need to know, the second thing that you need to have if you're going to go through the surgery is you need a very good neurologist. But they can't just be somebody who knows what they're doing. They have to also know you very well. I was lucky enough somehow, 6 years before this surgery happened, 6 years prior to that day, I met this guy, Alfonso Fasano, I think is on the call as well, hopefully. And together we kind of started to, well, I started to badger him with all of the questions that I've kind of been badgering the rest of the field with ever since. At the time though, my questions were a little bit more naive and a little bit simpler. There were questions like, what is a neuron? What is an axon? What is a dendrite? All of those kinds of questions. And he was very patient with me, very patiently sat there and answered every single question that I had at the time. I've been very grateful to him ever since, and I've been very lucky. I know how lucky I am also to have that relationship with someone like him, and to have the confidence also to let somebody like him have the remote that now can control part of my brain as well, which is not a trivial thing itself. Last thing that I wanted to point out is that, or the third pillar, I should say, of DBS, is that you have to have a good family environment that you can come home to at the end of the day. So this is something I want to emphasize, that the surgery itself was not the toughest part of this operation for me. Despite what a lot of people might expect, and despite my own biases going into the surgery, that day of the surgery was not the toughest ordeal of this procedure for me. It was not the toughest thing that I've had to face ever since either. The most difficult thing was actually in the days and weeks afterwards. So I would identify about 3 or 4 days afterwards that were actually more difficult than the surgery itself. One was right after I came home, after the battery was put into my chest. I remember I was very, very weak, and I felt very nauseous, and I was sick for basically 24 hours afterwards. I went to sleep but I could see like the horror, like the look on my mom's face could tell me that I looked like hell, and that yeah, it was just a rough day to get through. Then I think about 8 or 9 days later, I had the stitches removed from my forehead as well. That was also a very rough day because it felt like the rest of the day as though my brain was kind of seeping through the cuts that were now open somewhat in my top of my head. That was also a very difficult thing to go through. And then since then, there's been 2 or 3 other episodes, I would say, where I would get kind of like manic thoughts running through my head, or I just experienced something that a lot of people would diagnose me as having mania at the time. Now, while that was a lot of fun to go through, I look back and I see, okay, maybe that wasn't so safe, or maybe that wasn't the best thing for me at the time. The reason why that happened, though, is because of the programming itself. Programming is a very tricky thing. It's very difficult to do. It's a very complicated process as well. Knowing how to actually program these devices takes a lot of training and a lot of skill. And it's not something that can be trivialized either, which is why people like Alfonso are so badly needed in the world, and why we need more people like him to actually help push us forward and to actually help us at the end of the day get to much better results for people like me. Because at the end of the day, that is what we're trying to do here. We're trying to help as many people as possible. All right, sorry. Now, the next picture is going to be very gruesome, so if anybody doesn't like that kind of stuff, you can look away. But this is what it looked like during my surgery as they're drilling inside my brain as well. So even for me, it's still hard to look at this picture, but I was awake for the whole thing as well. So I have like a very vivid memory of what's actually happening like here and right before this. And I guess I'll talk a little bit about what was the most difficult part of that day of the surgery, which was the drilling of the boreholes, which happened just prior to to what you're seeing right there. But the drilling of the boreholes was something like I wasn't really prepared for. I didn't really understand what it would feel like going in. But I guess the best way to describe it is it was the first time that I've ever experienced in my lifetime where sound was coming from, it wasn't coming from the outside in, it was coming from the inside of my brain out. That's what it felt like. It's very much what it was as well, because my whole head felt like it was rattling as I was clamped down in that giant vise that you see around me. And as I could kind of feel, I mean, once they get past the skull, it becomes pretty easy in some sense because you don't feel anything. There are no nerve endings in the brain. And I can now know that, and I can attest to that very, I can attest that very succinctly in that I barely felt anything after they actually went through the skull itself. Although getting through the skull is very difficult, and I'm glad that I have a thick enough skull to actually kind of, be able to put up with the procedure itself. But yeah, the drilling of those boreholes were not an easy thing by any means, and I look at this picture from time to time, and I'm just like, wow, I can't believe I actually went through this for myself. I can't believe that this is something that I actually went through. It's still hard for me to process properly. It's still hard for me to believe that I went through this for myself. But at the same time, I also learned something else that's very valuable for me, because I know that if anything happened, I could do this again. I could, if I ever needed to, actually go through it, and I'd probably turn out okay at the end of the day. It's not something that I ever want to go through. If I had the choice, I wouldn't go through it. But yeah, that was that day for me. Now, the next thing I want to talk about is the MDS UPDRS scores, and especially the fourth part of that. So if you look, I think a lot of people on this call will be very familiar with the UPDRS, and the fourth part of the UPDRS in particular, the motor scores that are associated with it. Also, a lot of people here at the NIH, they saw me talk about last February, I believe, last January. I'd be curious to know, if anybody's willing, what score do you think I had on my UPDRS score right before my surgery, or even the year before when you saw me last time give a talk? Would anybody venture a guess as to what they thought my score might have been either before the surgery or a year prior when I was giving a talk last time here at the NIH? How about I go and put Mark on the spot and ask him? It's okay, you don't have to actually answer. So about a year prior, I would say my UPDRS was about a 40 point. I had about a 40 points on that score. Right before the surgery though, and by the way, every time you go and do the UPDRS test, you have to go, the best way to do it is you have to wake up very early in the morning, go to the hospital, go through the traffic, get there somehow. And then at the end of all, you have to be off your medications for many, many hours, just so that they can actually record your UPDRS score. And for those who have no idea what I'm talking about, the UPDRS is more like, I think Michael J. Fox put it pretty well when he said it's like an elaborate drunk test. But right before my surgery, I was getting about a 60 on that same scale. After the programming was finished, I was down to about a 25, but that was on the continuous settings. And now with these new adaptive settings that I have, and I'm happy, yeah, I can't say too much about them, unfortunately, right now, because I'm in a clinical trial and there's all sorts of like laws that I'm governed by, and there's all sorts of things that I'm bound by. But I think I'm down, last I saw anyways, down to about a 12 or a 13 on that UPDRS scale. So it's almost a 50-point improvement. Now, the reason why I'm telling you all this is because I want you to think back to all those drugs that I talked about before and all those other therapies that I mentioned. It's hard for me to ever think of anything that could have a similar outcome or similar improvement to DBS. Now, of course, that's not the only measure that we're going to use. That's not the only standard that we should be using either, because the surgery is complicated and it can lead to many different kinds of complications as well. However, just knowing that and knowing, like, being very aware of the fact that how good I feel right now, how much better I feel now than I did before the surgery. I don't know, just help put things in perspective for me, and I hope it does for others as well. And one other indication might be the medication that I'm on. So I'm down from over, I think I was about 400 or 500 milligrams of levodopa before surgery. I'm now down to about 75. And to be honest, I don't even like taking it anymore because I usually become dyskinetic soon after. Or I can become a little bit dyskinetic if I take too much. And so I'm hopefully going to be arguing, or I don't know if Alfonso wants to make those decisions right now, but I think soon I'll be able to stop it altogether again, but we'll see what happens there as well. Also because, you know, dopamine floods your whole brain whenever you take it. And so you don't want to just shut it off like that either. You want to give your brain time to adjust and to adapt to that changes. But all of this everything I just said about the UPDRS, it's kind of in some ways it's kind of like, what does it actually mean for people like myself? What does it actually mean for a person like me? And at the end of the day, how much better do I actually really feel? Like I can throw those numbers at you, but they don't really tell you anything. However, to try and explain it, I think you would have to have Parkinson's to really understand what it's like. But maybe this will help some people. So prior to my surgery, I would say that on-off fluctuating wave, that's what I felt every 2 or 3 hours of the day. I'd go from on to off, at least 5 or 6 times in a day, depending on, you know, how well my medication happened to be working on that day. During the on-off fluctuations, during those crazy spikes, I would not be able to really do anything. I wouldn't be able to really contribute to society in any way, conceivable way, because when I was dyskinetic, I was too dyskinetic, meaning the only really comfortable position I had at the time was to be on the floor, closing my eyes and trying to relax until the dyskinesia went away. However, that'd take about an hour before it actually started working. And then the other thing was when I was off, I was too bradykinetic also to do much of anything at that point either. Meaning I was too stiff and too rigid to actually be able to function as a, you know, more or less proper person, as a normal human being. Now, this graph I drew this graph, I think like 3 months ago, and that blue line represents what I felt after that. So that was after the continuous settings were more or less optimized. However, I'm much closer now to that black bar in the middle where I don't have those fluctuations anymore unless, you know, I take levodopa, unless I take my levodopa on an empty stomach. Otherwise, those fluctuations are almost completely gone from my life. And I feel like I can be somewhat able to contribute, able to do the things that I want to do. I'd say all but maybe half an hour to an hour per day. So I'm very thankful to DBS for that. So now some of the lessons that I've learned along the way. So like the take-home messages is one, I've gained perspective on what it means to, I think, be more of like a well-functioning human in some ways, but also I've gained perspective on some other things as well. I've gained perspective, I think, on biology itself. And I want to use this as an example to help me illustrate what I mean here. This is what I learned in school. So when I was a kid, this is what I thought of as the solar system. In my head, this is what it was. We have these, well, at the time there were 9 planets, but it's not really that important. However, I do have a question I'm going to ask somebody to chime in. Maybe actually I'm going to ask somebody. Yeah. So I have 2 but if you've heard me give this before, obviously I don't want you to give the answer. But there are two things that are fundamentally missing from this picture right that's in front of us right here. There are two fundamental parts of our solar system that are not depicted at all in this picture. What are those two things that are missing from this static image that you're seeing in front of you? And I don't mean things like asteroid belts or moons or those kinds of things. Think about something that's more fundamental than any of those things. I'll give you a minute though, or however long it takes, since somebody wants to chime in and see if they can give me the answer. All right, well, in my opinion, those two things are space and time. Whenever you're looking at any kind of model of any system, and whenever you're trying to model anything in our world, I think if you're not incorporating space and time properly into your model, you're missing so much information, so much that you can't grasp unless you incorporate those things into them as well. What do I mean? Well, look at this. While this is still not perfect, this is a much more accurate depiction of what I think our solar system really looks like. We're not just on a static planet that's hovering around the sun. We're actually spinning in this vortex around this fiery ball through space and across time. Now, I want though, what I'd like you to think about, especially the people here at the NIH, is to think about your models as well that you're using to model these diseases that you're studying. If there are static images in your mind, or even if the papers that you're writing, if they're all static images at the end of the day that you're trying to portray to the world, then I think you're really going to be missing something very crucial. There's always going to be something critical that you just can't see because you're showing the world an image, or you have an image in your mind. You really need to be able to close your eyes and think about in 3D and across time what is actually happening at the cellular level to any of these model systems that you're working with, or any of these, or any of the real systems that you're working with as well. In my opinion, if you don't have that, well, I would say in my opinion, the best scientists that I've come across, the best people, best researchers as well, they have that ability. They can actually close their eyes and they can think about the problem for themselves, and they can try and model it in their own heads. At the end of the day, I think that all of the best models that we have of Parkinson's disease or whatever disease that we're studying, they don't exist on paper and they don't exist on a computer even. They exist in the minds of human beings, people like the people working here at the NIH, because there's just so much information that gets lost in any static image or any kind of picture that you might try and depict. So yeah, we'll move on though to the next point that I want to make. So coming back to this, I've started to rethink how much do we really need to know to actually understand what it means to have Parkinson's disease or any of these other diseases as well. Which of these fields is actually important to understanding what this disease is, and then helping us all make progress at the end of the day. I think, and take this for what you will, but I've come to believe that, or maybe belief is the wrong word, maybe hope is a better word, but I'm not exactly sure at the moment. I think that if we were to understand this a little bit better, and I'm going to come back to that first image that I showed you now. I think that in there's a heuristic that we might be able to apply that might then be able to help us better understand everything that we're learning about this disease and about the brain and about how it actually works at the most fundamental levels. Now, fundamental levels doesn't necessarily mean the bottom either. When I talk about the most fundamental level of anything in our world, I don't necessarily think that we need to understand every single detail to understand the whole. What I think, or maybe what I hope, or what I believe anyway, is that if you really want to grasp something, you have to be able to understand where you can interject. What is the best point for you to actually intervene in the process that you're talking about? It doesn't always have to be at the bottom. If we have to understand every single gene and every single thing, every single RNA strand, every single protein, if we're ever before we understand these diseases, then I think we're going to be sitting here for a long, long time trying to kind of spin this wheel and trying to understand things. So like I said, which kind of heuristics can we apply? Coming back to this image now. Again, close your eyes for a moment and try to just picture this in your mind. Picture it, what it is, or take a look at it again. Try and grasp it and put it in your brain if you can. And then take a moment and just think about what it could represent or what it could mean as well. And I'll give you my answer in a moment. But just take one more moment and just think about this. Okay, So what I think this is, I think it's actually a pretty good illustration of the closed loop nature of how the circuitry in our brain works. What I think of is basically this. Imagine you were able, so again, you have to have that image in your mind so you can actually picture it for yourself and imagine it. But try to zoom in on any of these little clusters of light bulbs that you see in front of you. Close your eyes and try and actually zoom in and try and look at what they look like at the fundamental level. Picture them, if you can, as neurons themselves. Now imagine what happens if you were to close your eyes and one of those neurons were starting to blip out. For those like Sarah or Megan or anyone who was with us yesterday at the exhibit, they did a very good job of illustrating for everybody that was there what it looks like when a neuron actually dies and when it starts to die back. One of the first things that happens is it actually starts to lose connections with things that are around it. Now, then those other things, like for any living thing to be alive or for anything to actually be in this world, it has to be able to communicate with the things that are around it. Communication doesn't just mean though sending a message out into the world. It has to also be able to send messages back through. So there has to be some input and some output. All living things need that to survive. There's no such thing as a living thing that can't communicate in that sense with this world and in this environment. I think it's the best definition that I've ever come across what it means to be alive is that you can communicate, meaning that you can actually give a message out and then you can get a message back through as well. It's also why I think that adaptive DBS is working so well for me right now. Again, this is just a hypothesis. This isn't just a theory, it's just something that I'm kind of throwing out into the world. But the more I think about it, the more I think that there's a truism there. There's something very true about what I just said. That ability to actually adapt to your environment, meaning, so what's happening in my brain is that there's these beta waves that are fluctuating through my brain. There's receptors at the end of the electrodes that are deep in my STN that are reading those beta waves, and then the stimulation is actually adapting accordingly. The reason why in the past, why a lot of these systems that didn't work very well before is because they were dumb systems. They were just systems that were just operating like these stupid machines that a lot of us have. They're just firing all at once. Like it was just a continuous stream of electricity that was never changing based on its inputs. This one's actually changing based on the inputs that it's getting from the brain, from the rest of the regions of the brain. It's why I think it's why I think this adaptive kind of DBS might be working so well. It's also why I think that we need to be spending more time thinking about how is this actually working so well? Why is adaptive DBS system actually, what is it actually doing in my brain? And how is it working so well for me in particular? Because I mean, there's not a lot of examples that we can use to actually study this at the moment. I'm the first, I think I was the first or second person in Canada. And I know I'm one of the first worldwide as well. One of like a first 100 or first couple hundred to have this kind of adaptive DBS system actually in place. I would love if I could to talk to the other patients and see if they are having a similar effect or see how much better that they're doing compared to their continuous DBS settings as well. Because I think that the reason why it's working so well is exactly what I said, because of that ability to change and adapt to its environment and to the signals that it's giving us the ability to then give new insights into what this whole disease process is. So again, close your eyes and imagine what's happening at the cellular level. Imagine what happens when one neuron blips out and then the next one beside it also blips out. And then think about the ripple effects that it has to the whole circuit that it's part of. And eventually when enough of those neurons actually start to flicker out in any one area, the whole network gets affected. The whole circuit gets affected as well. And yeah, with that though, I'm going to be finishing my talk for now. You can see here though, if anybody wants to contact me, feel free afterwards. Or if you have any questions, I think we have about 15 more minutes left. Yeah, thank you for listening to everything that I had to say. And if you want to reach out, you can use any of these channels to reach out to me afterwards. And I would also love to hear from the people here if you have any competing theories as to why adaptive DBS might be working so well. Feel free to either say them now or send them to me afterwards. But yeah, thank you all for listening and thank you all for hearing that spiel. Thank you very much. Back to Sarah.
Thank you so much, Ben. This was a fantastic talk, as always. We love to hear you. Very inspirational. You actually have several comments in the chat. And now, if anyone would like to speak up for any questions, please feel free to do it. I wanted to actually ask you a couple of questions. So the first one is, when you think about all that's happening in Parkinson's disease research, I would like to know from you, what are you most excited about? And what is as well something that really frustrates you about?
About research in general, or like a specific brand of research?
Yeah, in general, about PD research.
Yeah. So I think one of the most frustrating things for me is what motivates scientists to do what they're doing, or not just scientists, but researchers, patients, doctors, everybody. I wish that there was something that could actually align us all and make sure that we were all on the same side of this disease. I think there's a lot of people that they enter this. I think everyone who's in it right now, they've entered with the best of intentions, and they all hope to make a difference at some point along the way. However, the more you go, the further you realize that the things that actually drive you forward, the things that incentivize you to do your best work, they don't always translate to patients, or the things that don't actually make any real world impact at the end of the day. I think we all have like this intuitive understanding of how to help people or what needs to be done better. But to actually implement those things is very, very difficult. And especially when you're in a giant institution of any kind, really. Because there's so many different like things that push and pull you in different directions that don't necessarily help people like me at the end of the day, or patients like myself. So yeah, that's something that frustrates me like time and time again. And where I draw the most hope and the most inspiration, I guess, is from things like adaptive DBS, but also like people like Alfonso Vazano. I hope is still on the call as well. And doctors like him, and also researchers like all of you working here at the NIH and everyone else that's around the world. I know how hard you try. I know that you're trying your best to actually help people at the end of the day. I know all of you that you wouldn't probably even be on this call if you didn't actually want to help people like myself. So thank you for all of that, and thank you for everything that you all do every single moment of the day. Even though I wish like we could, actually my question for all of you would be, what could I actually be doing at this moment to help lift some of those barriers as well, to make sure that all of you, not to make your jobs easier per se, but like to make it so that whatever you think will help people at the end of the day actually has its shot. So I think all of you are very well aware of how difficult it is to actually get a drug through the clinical trial pipeline and into people. What could I, as a patient or as a patient advocate, what should I be advocating for? Or what could the patient community be doing a little bit better to help all of you do your jobs better as well? Yeah. Who wants to take on that? Oh, and Sarah, feel free to interject with your news at any time if you want. I think everyone wants to hear that.
You are the superstar here today, Ben. So yeah, this is a fantastic talk, and really like, oh, Mark has actually a question. I think you are doing already an amazing job trying to bridge those gaps that exist between the patient community and the research community, and we are learning a lot from you. And I think these type of talks are very important for us to remember why what we do is crucial in our daily basis, because this is at the end to help you and people like you, right? And so it's something that we always try to keep in mind every day. So it's great that you join us to remind again why it's important.
Thank you. I'm just going to scroll through and see if there are any questions in the chat box.
Yeah, I think Mark wanted to say something. Go ahead, Mark.
Yeah, so thanks, Ben, as always. You're talking about your adaptive DBS and how effective that be. And I know I didn't speak up with rating scales, so I'm not actually very good at those things. But anyway, what do you think the end game is for a Parkinson's patient now, someone living with Parkinson's, given that there's all this improvement in care and motor control? Where do you think we should be aiming for in terms of saying, we've made an impact?
It's a very difficult question. I think at the end of the day, it comes down to the individual. I mean, if the individuals that you're trying to help do not feel like they're living a better life today than they were yesterday or the day before, then we're falling short in some ways. Yeah, the UPDRS is one measure of how we can actually get there, but at the end of the day, there are no good measures. There's nothing like great that we can point to and say, yes, look at this wonderful new scale that I came up with, this new rating system that's going to be the end all that we have, and then we don't have to worry about this, and now we can just worry about making drugs that can actually help improve this rating scale or whatever better. I don't think that's possible to do, given all the variability and all the heterogeneity in this disease, and given all the variability between one individual to the next. I mean, it's like really everything else. Like, how do you even measure? I think it's akin to measuring how good a scientist is as well. I mean, we don't have any good ways of measuring who's a good scientist from who's a bad scientist. We give out prizes and we say a lot of things, but at the end of the day, there's nothing that can actually like point to and say, oh, this rating scale means that this person deserves the Nobel Prize and this person doesn't. It's all biased. It's all based on our lived experience. It's all based on our intuitions or whatever you want to call them. So I think maybe it's akin to that problem. If we could figure out a good rating scale for who's a good scientist versus who's a bad scientist, then maybe we can figure out what it means for a patient to actually improve along their progression. I hope that was somewhat of an answer, but I'm not exactly sure.
No, I mean, that's similar to what other people have said, that, you know, people's reactions to treatment and what they're looking for in treatment is very difficult, very individualized, right? Some people prefer to be a little, or will take being a bit hyperkinetic. Some would rather be a little sort of under on that. So it is very individualized, and sometimes we forget that, don't we? Thank you.
Yeah, and I actually really like the quote that you gave as well in the chat box. I just want to read it real quickly for everybody. Since all models are wrong, the scientist must be alert to what is importantly wrong. It is inappropriate to be concerned about mice when there are tigers abroad. I think that's a very eloquent way of stating exactly the kind of thinking that a lot of people, I think, need to be more attuned to and need to be adopting a little bit more widely. Yeah, thank you.
Yeah.
Any other questions? I saw a lot of people pop up their faces.
You actually have a couple of questions on the chat and another question from Dr. Fasano as well. So the questions from the chat say, was there an option to do your surgery while asleep?
So yes, there's always the option. I mean, if your surgeon looks at you and you look very uncomfortable, or if you really chime in and you say, I can't do this awake, this is crazy, this is barbaric, how can you actually try and do this to me? Then yeah, they'll put you asleep. But I think it's important to try, at least at the beginning, to try and get through it awake, because at the end of the day, the job of the surgeon is to make sure that the electrode's in the right spot. And if it's not in the right spot, then you're gonna have trouble all the way down the road. And if you wanna help them, then you need to be awake so that you can help guide them through it. Now, not everybody can be, not everybody should be, because if you have such like terrible anxiety beforehand that it's gonna actually interfere with the surgery itself, then you probably shouldn't be. But try at the beginning, at least if you can, to try to put yourself kind of paradoxically in the shoes of your surgeon as well. Make sure that they have everything that they possibly have to do their job a little bit better. I think.
Yes, you have another one. Do you wish you had done DBS earlier?
That's a very difficult question. I'm actually gonna throw that one to Alfonso because I'm not sure. Yeah, what do you think, Alfonso? Do you think I should have? Sorry, Dr. Fasano, but do you think I should have had this a little bit earlier than I did?
No, I don't think so. For a number of reasons. First, we know that if we do surgery too early, there's a chance that the patient is disappointed. In a way, we want the patient to be affected enough so that the difference will be more remarkable. Ben just mentioned the UPDRS, and you can tell from the numbers that he needed something more. But I guess I'm not telling you anything new when I say that Ben is not an easy patient to please. So I was really careful before saying anything. And but at some point, there was nothing else we could possibly do to improve his quality of life. And when you see this remarkable difference, this is when the patient is eventually happy about the results. And I should emphasize that results are never 100% what you wish for. I mean, Ben is doing well, as he said, but things can be done always a bit better. The second reason I don't think he was needed to do it to be done earlier is that, as you can imagine, Ben was also looking for other ways to help himself, and unfortunately, many clinical trials these days are excluding patients who had undergone DBS. So I guess where we had many conversations, as you know, Ben, about it and what best option you had on the table each time we talked about it. And looks like no real clinical trials was appealing. And at the same time, the quality of life was deteriorating. And this is when DBS became the only solution. So this is, I think we did it at the right time. You agree? Good. I like when you agree.
I have a question for you, Dr. Fasano, if you don't mind.
Yeah, sure.
Because I think this audience might be curious to know about something. Because I think I had a pretty good outcome, but obviously my outcome is not what everybody experiences who goes through something like this. I'm wondering if you could tell a little bit about what could have gone wrong for me, or what you see that often goes wrong for other patients as well.
Before I answer this question, I just want to add, and that's why I raised my hand, because I forget, I'm getting old and I'm on call too, so I'm not sleeping well at night. So I'm afraid of forgetting what I wanted to add to the questions that were asked before, what else can be done now to improve the quality of life, the end game, as it was said before, for Parkinson's patients. And I think, and this is partially answering the question you asked me, Ben. Whatever we do, we are never able to restore the function, the motor function. So we always improve, let's call it UPDRS, like the best we can possibly see is an improvement by 80%. So there is, in the best possible scenario. So there is a minimum of 20% improvement that is we're missing. And this is coming from two different sources. On the one hand, we are not able to restore the striatal function, so we can do anything with dopamine-related therapy, or DBS in a way is working on the same circuitries. But in any case, we are not able to fully restore the activity of the striatum. Fine motor skills, we're not good at that. And second, axial problems, speech, swallowing, balance, gait, and that's why I spend most of my research time on these problems, which are eventually the ones that are really making a difference in quality of life terms. So we are not good at treating them at this point. So this is where we need to go moving forward. At the same time, we should also recognize that most of the funds are now going towards a cure, and in a way we are distracting the funding agency from better symptomatic therapies. This is a big problem we are facing in the research community. As for your question, Ben, what can go wrong? Well, many things, from surgical adverse events like hemorrhages, stroke, infections, to electrode displacement. These are things that don't do any good to the patient, obviously. But in your case, I think, Ben, the most problematic situation will have been an unhappy patient because the expectations were met. And this is obviously a function of your own expectations and your own functional needs, which in your case are pretty high because of what you do. So the worst case scenario is when the patient does all of it, go through the operation, and you saw the picture, and at the end of the day, you ask the patient, would you do it if you could go back in time? And the patient says, no, you know what, I would not have done it. I should say in my life, this very rarely happened. I would say 1-2% of patients, but it can happen. Lastly, there's a problem with impulsivity, as you mentioned before. There's also a problem with suicide, especially in young patients, when impulsivity is too much and the medication reduction is too fast. In the past, unfortunately, we have seen suicide. That's another terrible outcome, of course, which tells a lot about the expectations also. Yeah, that's the answer.
Okay, thank you very much.
And by the way, thanks as always for your kind words, Ben.
Well, they're well deserved, Alfonso. I do wish that everyone who needed it had access to doctors like yourself. A couple of things this is one other thing I wanted to talk about, though, about something else that one of the more adverse effects as well of my procedure of late is that I do have a very unhealthy appetite. Not unhealthy, but I do my cravings have greatly exceeded since then. I've gained almost over 40 pounds now since my surgery, which isn't the healthiest thing in the world for me, but given the options available to me and the outcomes possible, I continue to just live my life and try and be as happy and do the things that I think are good for me as an individual. Although there's a lot of philosophical questions I would love to get into now with Fasano, but I don't think we have time for that. And Megan, I saw, asked a question about what was it? At what point did DBS become the clear front runner for me, or how long is the decision-making process? I think, and Dr. Fasano, please correct me if I'm wrong, but I think I first started to broach the subject seriously back in January of this same year, and from then until June, we slowly went through the whole process. I met with the entire neuropsychological team. I met with the neuropsychiatrist, and then I met with the surgeon, I think twice as well. And through it all, and at each stage, it's kind of like graduating from one level to the next. Because if you don't go through the right steps, then so each step kind of has to give their own approval or their own stamp of approval and say, yes, this patient is okay for the next step, so to speak. As to what the other options were, so cell replacement therapy, gene therapy. However, the bigger one that I was considering was actually the levodopa infusion pumps. And honestly, if I had better access to that in Toronto, it might have actually delayed when I did this. Although the latest one and the best one is not available yet in Canada. So for that reason, it came off the table at some point. Yeah, I think that was the answer to that question. And then the next from Sue, how long might improvements from adaptive DBS last? That nobody knows. I don't think anybody could actually answer that question for you because we just don't have the data yet. Like I don't know how long these trials have been starting even, or when they began in the first place, but I know that for a fact that we just can't answer that properly yet. Yeah, I do have one question for everyone here at the NIH though, as well. I wish Mark were here, but maybe him and Andy, when he reviews this tape later, they can give us their answers as well. Why is DBS not something that is more studied at this point at places like the NIH? I mean, like the results have been pretty remarkable so far. So why is it that, because I know that everyone's kind of chasing these disease-modifying therapies. However, for me, and I think Dr. Zano would also say the same thing, it's very much been a disease modifier for me. I'm able now to live my life how I want to live, more or less, meaning that I can exercise properly, which we know is the only thing that's actually proven to be disease modifying. Now, I haven't taken full advantage of that quite yet, but I'm hoping to soon. But that very fact that I can now do all the things that I want to do with my life and that I can like live a much better life than I could before has allowed me now to exercise and to live a more healthy lifestyle in a lot of different ways. But I do very much, and also because my symptoms are my disease. And for a lot of patients, their symptoms are their disease. I can't feel proteins aggregating my brain. I can't feel my genetics. I can't feel anything else except the symptoms that I experience on a day-to-day basis. So again, I wonder, like, why do you think, in maybe the right people aren't here yet, but aren't here anymore, but why is it that the NIH just doesn't seem to, not that they don't care about this, but that they just either skirt around it or they're just not focusing any kind of effort on DBS itself? I mean, I'm sure that there are some people here, but compared to what's going on in the genetics field, it's very minimal.
Yeah, you do have a comment on the chat. So Mary says, to the best of my knowledge, there are a few labs at the clinical center specifically looking at DBS and its outcomes and success rates. Yeah, like our group really focuses more on genetics and cell biology, like it's Mark Coxon's lab and so on. But yeah, it will be great because we had actually prepared some slides for you, Ben, but I know it's almost time to go. If you would like to join our next molecular genetics section seminar in 2 weeks from now, or I think perhaps we will postpone it after Christmas. So we have some slides to communicate and to get your feedback as well. And I think this will be a great opportunity to keep discussing this topic.
Yeah, I love that. Thank you very much. And yeah, to Maria's point, I take what you're saying, but I look like broadly at the field, and I would say that if you look at the amount of money that's being spent on advancing genetic therapies or molecular-based therapies versus what's being done for DBS, I mean, I might be wrong, but it seems the balance doesn't seem to be quite right to me, in my mind anyway, especially when you look at basic biology in particular. I don't know any basic biologists or any cell biologists that even work for some of the larger companies. I'm sure there are a few, but there are very few that seem to actually take an active role in trying to understand why, all the whys and hows that we have about this disease and DBS in particular. Whereas compared to genetics, seems to be a lot more there. But yeah, as Sarah said, I think our time might be up though, so I don't know how much we can actually get into that. But yeah, just my observation, what I think at this point.
Yeah, that's fantastic. Yeah, we can keep discussing definitely this in the next meeting. So thank you so much for your talk. It was great, fantastic. And thank you everybody for attending. We have recorded the session, so we'll circulate it with Ben later on, and you can feel free to share it. I know you, Ben, you also started a thread on Twitter, so we can keep posting further questions there and continue the discussion. So thank you so much.
Awesome. And thank you, Sarah. And congratulations to you as well for, I don't know if you want to tell it now, but yeah, congrats to you as well.
Thank you. Thank you so much. Take care.
Thanks, Ben. Bye.